Most people imagine a black hole to be a starving monster with a gravitational pull so strong that nothing, including light, can escape it. As soon as something reaches the event horizon, aka the point of no return, there's no way back. But then, how about information? Quantum physics, which describes how everything in the world works, claims that nothing can destroy data. But if this nothing includes black holes, well, then we have a paradox on our hands. That's when Stephen Hawking came up with a new idea. Can it be that black holes don't have event horizons? Instead, they may have apparent horizons. Those can only trap stuff for some time. After that, matter or energy will escape, but in a different form. It means that black holes won't be able to wipe information, just change it. If this theory is true, and there's no event horizon, then there are no black holes as we know them. Is there going to be a big crunch, a big rip, or a big freeze? Yeah, I know where you can get a big gulp. Many astronomers agree that the universe might end some 2.8 to 22 billion years from now. If the universe is expanding, and it is, it means it was born from a much more compact state, like Rhode Island. And if it does have a beginning, it's likely to come to an end too. But scientists can't agree on the way it'll happen. One of the most popular theories is a big crunch. Not Captain Crunch. Once the growth of the universe slows down to a crawl, the gravity will become the main force. It'll make the universe shrink, causing planets, stars, and galaxies to collide with one another. It'll be the Big Bang in reverse, with everything collapsing in on itself. The Moon is the closest planet satellite to the Sun, since Mercury and Venus, which are closer to the Sun than Earth is, don't have satellite. Maybe they have cable. With an average diameter of 2,159 miles, the Moon is the fifth largest satellite in the Solar System, after Jupiter's satellites Ganymede, Callisto, and Io, and Saturn's Titan. We can see solar eclipses pretty often, but moon eclipses only happen once every several hundred years. The Moon looks as if it were the same size as the Sun. The star is about 400 times bigger than the satellite, but astonishingly, it's also 400 times farther from us. That's why they seem to be equal in dimensions as viewed from the surface of the Earth. Although the Moon seems really bright, its ability to reflect sunlight is 3 times less than that of Earth. That's why, in combined photos, they make the Moon look brighter artificially. It would take about 300,000 moons to produce as much light at night as there is in the afternoon. About 206,000 of them would have to be full. The Moon is getting 1.5 inches farther away from Earth every year. At first, it was about 14,000 miles from Earth, and now nearly 250,000 miles. In about 600 million years, its visual size from Earth will be so small that there will be no full solar eclipses. If you're still around then, leave me a comment below. The Moon causes high and low tides on Earth. The gravitational influence of the Moon has this effect on oceans. The highest tide can be seen at full or new moon. There are huge temperature fluctuations on the Moon. Close to the Moon's equator, the temperature rises from minus 279 degrees Fahrenheit at night to plus 260 degrees Fahrenheit in the afternoon. I think I dress in layers. Trash isn't just a problem in Earth's oceans, cities, and forests. There is a thing called space junk, which is any human-made object that's been left in space and now serves no purpose. There's also natural debris from meteoroids and other cosmic objects. There are currently over 500,000 pieces of space debris orbiting the Earth at speeds high enough to cause significant damage if they were to collide with a spacecraft or satellite. NASA does its best to track every single object to ensure that missions outside Earth can reach their destination safely. Have you ever looked up at the night sky and tried to count all the stars? Yeah, good luck! Our galaxy, the Milky Way, not the candy bar, the galaxy, has about 100 billion stars, but other estimates put it at over 200 billion. Since calculating the exact amount is an almost impossible task even for astronomers. As for the entire universe, There are at least 1,000,000,000,000,000,000 stars. That's a 1 with 21 zeros after it. For comparison, that means there are more stars in space than there are grains of sand on all of Earth's beaches. When the planets in the solar system were just starting to form, Earth didn't have a moon for the longest time. It took 100 million years for our natural satellite to appear. There are several theories as to how the moon came into existence, but the prevailing one is the fission theory. Is that where somebody went fishing, caught the moon on a hook, and dragged it over into Earth's orbit? No, I made that up. The fission theory proposes that the moon was formed when an object collided with Earth, sending particles flying about. Gravity pulled the particles together, and the moon was created. It eventually settled down onto Earth's elliptical plane, which is the path that the moon orbits. A trip to the nearest star apart from the Sun would take you 5 million years on a commercial airplane. That's what I call a long-haul flight. It would take you about 100,000 years to travel from one end of our Milky Way galaxy to the other at the speed of light. On a plane, that's just too many zeros to fit into a single screen. The Sun can fit about 1,000,000 Earths inside it, but there's a star called Scuti that's about 1,700 times larger than the Sun. Almost everything in space is connected with everything else by gravity. Star systems are part of galaxies, galaxies are part of clusters, and clusters are parts of superclusters. The largest known supercluster in the universe is the Hercules Corona Borealis Great Wall. That's a name. It's more than 10 billion light-years wide. Mars has the largest natural formations in the solar system. The mountain 3 times taller than Everest, the canyon almost 7 times longer than the Grand Canyon, and the crater that could fit half the Amazon River across it. Although the Big Bang Theory is the most viable one, researchers still find evidence against it. For example, one theory suggests there's an axis around which the whole universe rotates. It's aptly named the axis of evil. There's a supermassive black hole at the center of almost every major galaxy, including ours. Black holes can attract not only stars and planets, but also other black holes, eventually merging and becoming one with a much greater mass. The spinning movement and enormous gravity of black holes sometimes makes it throw jets of matter into space, traveling at almost the speed of light. There's a thing called the Great Attractor. It's a gravitational anomaly outside our galaxy that can't be seen but is known to attract the Milky Way and lots of other galaxies toward itself. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. The Moon's gravity is only 17% of the Earth's. If your weight was 100 pounds on our home planet, you'd only weigh 17 pounds on the Moon. You would be able to walk a distance 6 times longer and carry a weight 6 times heavier there. Or just hire somebody from NASA to carry it for you. Though it's easier to walk on the Moon, it's more dangerous too. An astronaut's foot in a heavy spacesuit sinks into the Moon's ground up to 6 inches deep. Long-distance jumps are uncontrolled and dangerous because the Moon's surface is full of deep craters. One of the things Jupiter's famous for is the Great Red Spot, a giant spinning storm. This phenomenon used to be so gigantic that it could fit 2 or even 3 Earths. But the spot is shrinking. Right now, it wouldn't fit more than 1 Earth. If 2 pieces of the same kind of metal touch in space, they bond and get permanently stuck together. It doesn't happen on Earth thanks to water and air that keep pieces separate. The Moon is not an ideal sphere. It's shaped more like an egg because of the Earth's gravity. The base of the egg shape points toward our planet. Normal visible matter, for example planets and stars, make up just 5% of the universe. The rest consists of invisible dark energy, that's 68%, and dark matter, about 27%. It leaves us with 95% of space we know nothing about. The mysterious Kuiper Belt lies behind the orbit of Neptune. It's filled with massive icy objects. The most curious thing about this phenomenon is its movement pattern. The only explanation astronomers have: Neptune is hiding a ginormous planet. This hypothetical planet has already got the name Planet 9. All we have to do is wait until its existence is confirmed, or not. You won't be able to wear a hat on Venus, ever, and just try to stand on your feet. The planet is insanely windy. Its upper winds blow 50 times faster than the planet rotates. What's more, these fierce winds never stop and can get even stronger with time. Want to get away? You'll have to travel 11 billion miles away from Earth before ever leaving the solar system. Take your Google Maps with you. You probably heard of methane gas, a byproduct of natural processes such as volcanic activity and cows. Anyway, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be cows on Mars? As you may remember, Pluto used to be a planet but was stripped of this title in 2006. Later, it was reclassified as a dwarf planet. Gee, make up your mind. But the most unexpected fact about this celestial body is that its diameter is smaller than that of the US. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,800 miles. As for Pluto, it's only 1,473 miles across. In fact, if you laid Pluto right down in the middle of the United States, you'd crush the heck out of Iowa, Kansas, and Nebraska. Bad idea. The planet Uranus, or Uranus, you can't win either way, rotates on its side, and astronomers have no idea why the planet has chosen such an unusual position. The culprits could be ancient mega-powerful collisions, but so far it's just a theory. By the way, this is the only planet laying on its side. Our Sun is insanely massive. Want some proof? Well, 99.86% of all the mass in the solar system is in the mass of the Sun, in particular the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. A light year is the unit of distance covered by light in a single year. Light moves a little more than 186,000 miles per second, so 1 light year is almost 6 trillion miles. Which reminds me, our Milky Way is 105,700 light-years wide. Really, trust me. There's a whole lot of water floating in space. Astronomers discovered a huge vapor cloud that's 140 trillion times the mass of the Earth's ocean water. But don't worry, it's 12 billion light-years away, so we won't drown in that stuff anytime soon. Saturn's rings weren't discovered all at once. It happened gradually, and they were named alphabetically based on the time scientists found them. They go like this: D, C, B, A, F, G, E, which of course spells Dick Bofke. There's a giant red spot on Jupiter that's bigger than Earth. Astronomers confirm that it's a perpetual storm that has been going on for centuries. Color me weightless. Astronauts only wear orange spacesuits during launch, landing, or when they're in the spaceship for survival and rescue purposes. Their white suits are equipped differently to help them survive in outer space. The closest neighbor to our Milky Way is the Andromeda Galaxy. It's 2.5 million light-years away, and you can see it on a clear night with an unaided eye. And, by the way, in a little more than 4 billion years, our galaxy will collide with the Andromeda Galaxy. According to some predictions, the galaxies won't survive, but our solar system will. Place your bets. It takes 243 Earth days for Venus to complete a rotation around its axis, but it takes 225 Earth days for the planet to orbit the Sun. That means a day on Venus is longer than a year. Now, we always see the same side of the Moon no matter where we are on Earth. That's because the Moon rotates around the Earth at the same speed it rotates around its own axis. Outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. One phenomenon people should be worried about while exploring space is cold welding. If two pieces of the same kind of metal touch in space, they bond and get permanently stuck together. It doesn't happen on Earth since water and air keep pieces separate. Astronauts on board the International Space Station don't use their feet to walk, they float around. So in orbit, the skin on their feet becomes very soft and starts to peel off. That's why they have to take their socks off very carefully. Otherwise, skin cells will break free and float around in the almost weightless environment. Earthquakes on the moon, or more correctly, moonquakes, aren't something from science fiction. They don't occur as often as on our planet. And when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of the moons of Saturn, Rhea, might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time people discovered rings around a moon. Hey, that's nothing. I've had rings around my collar for years. Normal visible matter, for example, planets and stars, makes up just 5% of the universe. The rest consists of invisible dark energy, that's 68%, and dark matter, about 27%. Add it up, and there's 95% of space we know nothing about. In its darkest areas, space is freezing cold, minus 454 degrees Fahrenheit. But try orbiting Earth in the sunlight, and you'll understand how scorching 250 degrees feel. That's one of the reasons astronaut spacesuits are white. This color is the best to reflect the heat from the sun. Astronauts can stay on ISS for so long because the uppermost atmosphere protects them from solar radiation. At the altitude above 310 miles, there are radiation belts that have a destructive impact on humans. And then, if ISS rises too high, the Earth's gravity will become too weak to hold it, and it will leave the Earth's orbit. That's why those super guys have to train hard on special zero-gravity simulators before they go into space. But there is zero gravity in open space, isn't there? You might ask. Or how would spaceships manage to fly to the moon or other planets? If a body is far enough from a space object, say a spaceship flying to Mars from Earth, the gravity of the space object will be too small, and their mutual attraction will roughly balance each other. But no matter how far the bodies get from each other, their mutual attraction never equals zero. The Earth falls down to the Sun the same way the ISS falls on Earth. But since its lateral velocity is big enough, it's been doing this for 5 billion years. But if planets and stars are stuck in their orbits for billions of years due to gravity, how come shooting stars appear in the sky? What we take for shooting stars are just small stones floating in space, and their orbit, or our orbit, makes us run into each other. When the objects meet our planet, they bump into our atmosphere at a high speed and squeeze the air in front of them. The speed is so high that the air gets super hot and starts shining. When you look at this from the ground, you don't see the shining gas and a stone behind it. It just looks like stars, the same as others in the sky, are falling down on Earth. Soon they go out before they make it to the ground. Since they are just hundreds of feet away from us, they seem to be the same size as true stars that are thousands of light years away. In science, shooting stars are called meteors. If parts of meteors do reach the Earth's surface, they are called meteorites. Super bright meteors are called fireballs. Hundreds of millions of meteors appear in the atmosphere daily. Their total weight can be thousands of tons. And about 100 tons of dust particles, which are too small to be visible in the atmosphere, fall down on Earth from space daily. Most of them just burn there without a trace. About 700 million years ago, I wasn't around then, a mysterious event that occurred may have turned Venus into the place it is now. Admittedly, astronomers can't see the surface of the planet directly because it's covered with dense layers of thick clouds. But space missions that have been sent to the hot planet found that Venus is peppered with fire-breathing volcanoes, massive mountains, countless craters, and gigantic lava plains. The temperatures on the planet are so incredibly high that they could melt lead, and the atmospheric pressure is so immense that it would instantly crush any living being reckless enough to set foot on it. If that's not enough, the atmosphere of the planet is filled with noxious clouds of sulfuric acid, which smells worse than rotten eggs. Carbon dioxide, the main component of Venus's atmosphere, along with the infamous sulfuric acid, creates a powerful greenhouse effect. As a result, the lower atmosphere and the surface of the planet are some of the hottest places in the whole solar system. But the newest scientific theory claims that Venus could have had a pleasant, stable climate for billions of years before something went wrong. Astronomers did thorough research and built a model of a virtualized Venus-like world. This model demonstrated that for most of its history, the hot planet had oceans with liquid water, adequate temperatures, and stable tectonic plates. In fact, the planet resembled Earth as it used to be at the beginning of its life. Scientists suppose that this period of Earth-like development could have lasted for more than 3 billion years. So, during that time, the planet was most likely covered with oceans, which were from 30 to 1,000 feet deep. Also, some water was locked in the soil of the planet. On top of that, Venus had stable temperatures of 68 to 122 degrees Fahrenheit, which, you have to admit it, were quite pleasant, and not that different from the temperatures on Earth nowadays. So, what I'm getting at is that for 3 billion years, right until something irrevocable happened 700 million years ago, Venus could have been habitable.